Good morning, everyone. I'm Steve James from Computer Science and Engineering Department, Karunya. Today, I'm going to explain about the user-defined function which is used in the Python programming here. I'm going to take 4 sample programs to explain my user-defined functions. So that I'm choosing some programs like I'm going to check a number whether it is a palindrome number or not, it is a perfect number or not, it is an Armstrong number or not, or it is a happy number or not. So with these 4 programs, I'm going to explain about the user-defined function here. Now let's go into the video and see that. Okay, this is my first program here, which is I'm going to explain about the palindrome number. First of all, what is a palindrome number? It's nothing but whether a number which returns its reverse of it also gives the same number, it is a palindrome number. For example, I can give a 151. It has 1, 5 and 1. Whether we take it in the reverse order of that, we will get again the same number of 1, 5 and 1. For example, we can take 1, 2, 2 and 1. Whether we can get the reverse order also the same as 1, 2, 2 and 1. It is a palindrome number. But in case of 1, 2, 4 and 5, whenever we get the reverse of it, we will get as 5, 4, 2 and 1. It is not a palindrome number. Now let's see it in the Python programming way using a user-defined function here. Now let's look into the video. This is my user-defined function here. These codes are my user-defined functions and these are my main functions here. Now I'm going to explain about my palindrome function here. First, I'm creating a user-defined function using palin and an argument with n. Now in that user-defined function, I'm going to take 2 variables with value 0. And I'm using while loop here and checking whether the n is not equal to 0. Because whenever the n is equal to 0, we cannot run the program, right? So I'm checking the condition first here. And now I'm going to run through the loop of r is equal to n mod 2. So that I can get the last digit of the number here. And I'll taking the reverse number here as into 10 plus the r number so that I can get the add up the reverse number of here in the variable. And now I'm getting the divisible divided by 10 so that I can get the previous number of the last number here. So again, this process will be going here and all the variables will be stored in reverse order here in the rev function. And then it returns the rev variable here to the main function. Now we'll see the main function here. First, I'm taking a n variable and getting the input from the user using input and int function. I'm taking the input from the user here. So whatever I give the input like 121 or 123, it will be stored in the variable n here. So now I'm calling the function palin using the n argument. Whatever I give here, it will be coming here. Using the n argument, I'm storing it in the reverse variable. So whenever I call the function, it goes to this function and it runs through its total process here. Okay. And it returns the rev variable here so that I can get the reverse number of that integer and it will be stored in the reverse variable here. So now through the if else condition statement, I'm going to check whether the n variable and the reverse variable, both the values are same or not. If both the values are same, it will be printing as the number as palindrome. Otherwise, it will be printing it as not a palindrome number. Okay, so we can check with this program. I'll run the program here now. Now it asks for the input here. Now I'm giving the input as 1, 2, 2 and 1. And I'm gonna through this because it is a palindrome number. I can see here 1, 2, 2 and 1, and in the reverse order also I will be getting the same 1, 2, 2 and 1. So I'm gonna get through this program. Look, I got the 1, 2, 2 and 1 value is a palindrome. So again, I'll run the program here with a different variable. Now I'm gonna check it as 1, 2, 3 and 4. Now I will be checking the variable here and I'll go through this program. Now it returns me it is not a palindrome number, because in this number, in the straightforward line, it gives 1, 2, 3, and 4, and in reverse order, it gives 4, 3, 2, and 1. So it is not a palindrome number. This is my first program, and we'll go to the next program in the second page. Yeah, look. In this program, I'm going to check whether the number is a perfect number or not. First, what is a perfect number? A perfect number is nothing but whenever a number of gets the sum of divisible numbers of that number, which gives the same integer value. For example, I can explain it with 6, because the divisible characters of 6 are 1, 2, and 3. Whenever I get the sum of these numbers 1, 2, and 3, I'll get the same value as 6. It is a perfect number. Now I'm going to explain these through this perfect number as with user defined function here and in Python programming. Now let's get into this program here. First I have defined the function here, and I have assigned a value L with value 0. Now I'm gonna through this for loop range. In this for loop range, I will be getting all the values till the before the number I'll get, and I'll check through this if condition what are all the divisible values of that particular number. So I'll get the divisible value here and I'll be summing up with L variable here. So L will be collecting all the sum of the variables which are divisible of that number. So I will be returning L to this main program. Now, whenever we check into this main program, first of all, I will be giving here N to get the input from the user, right? Whenever we need an input, we can get the input from the user. No, for that I am creating a N variable here. Like before in the same previous program, I have created a variable here and I am asking for the input, and I am creating another variable here and I am calling the function here perf with the variable N. So I'll get the variable here and it runs through the function process and it returns the L value here, which is the sum of the divisible numbers. And using the if else condition, it checks whether the sum of the divisible numbers and the number it is same or not. If the number are same, it is a perfect number. It will be printing it as a perfect number. If it is not same, it will be printing it as a not perfect number. Now let's run the program here. Look, it's asking for the input here. I'm gonna give 6. 6, we know it is a perfect number, but we'll run through this program. Yeah, look, I got 6 is a perfect number. Yeah. Now we can again go through the same program here with giving another number 5. Or we'll go with 4. Okay. With 4, whenever I give this, it is not a perfect number because the divisible characters of 4 is 1 and 2. Whenever we get the sum of these 1 and 2, we'll get 3. It is not equal to 4. So it is not a perfect number. Now we can check with the other program here. In this program, we are going to check whether a number is an Armstrong number or not. Do you all know what is an Armstrong number? It's nothing but whenever the power of the total number of digits it gives with the sum of the number, it is and returns the same value of the number, it is an Armstrong number. For example, I'll take the value as 153. It has 1, 5, and 3, right? It has 3 digits totally, okay? So we will be getting it the sum of powers. Okay, for example, it has 1 cube plus 5 cube plus 3 cube. It will be returning the sum of these value will be returning as 153. It will be in the same value. So whenever it is same, it is an Armstrong number. Whenever it is not same, it is not an Armstrong number. We all know that. So now in this program, I am defining an Armstrong function here with 2 arguments and parameters. One is to get the integer value and another one to get the total number of digits, or we can call it as power. We are going to use it as power here. So I'm assigning 2 variables here. One I'm assigning the value of 0 and another variable I'm going to assign with the x whichever value I will be getting here, I will be assigning it with here. So now I'm going through this while loop here. So with this while loop, I will be getting the sum of power of that number, and I will be getting totally stored in this sum. So I'll get the value here. So I will be returning the sum here to the main program. In this main program, first I'm getting the input from the user. Like in the same previous program, I'm getting the input from the user, and here I'm making the integer value as string number here using string function to get the total number of digits, or we can say it as size. So to get the size of a number or an total number of digits of number, I'm converting the integer to string here. So whenever I convert it to string, I can get the total number of digits with the using length function. I can get the length here, and I'm getting stored into yes variable here. So I get the total number of digits. I got the integer value also. And now I'm creating another variable, and I'm going to call the function Armstrong here with two parameters here, n and s. Whenever I'm calling this function, it will be going through this process, and it will be returning this sum value in the m variable here. So I'll be getting the power of sum in the m variable, and now I'm going to check through if else condition, the same if else condition, whether it is same or not. If it is same, it will be printing it as an Armstrong number. Whether it is not same, it will be printing it as not an Armstrong number. Now let's see through this run program here. Yeah, I am running this program here. It again asks the input here. So I'm giving it as 153. It has three numbers. So it will be having it as 1 power 3 plus 5 power 3 plus 3 power 3. And it will be giving this total sum as 153. So now I'm going through this program. Yes, 153 is an Armstrong number. Again with the same program, whichever number I get here, it will not go with that. For example, I'm giving it as 12. For 12, it has two digits. So 1 square plus 2 square. Okay. So 1 square plus 2 square, it returns a value as 5, which is not equal to 12. So it is not an Armstrong number. Look. Yeah, 12 is not an Armstrong number here. So we can confirm it here. So we can see the next program for the happy number. Yeah, in this program, I'm going to explain about what is a happy number and how I'm going to do this with the user-defined function here in Python. Okay, now first, what is a happy number? A happy number is nothing but whether the sum of square of that number will be going through a process till 1. Whenever it gets the answer as 1 through a running process, it is a happy number. Otherwise, it is getting a value as 4, and it will be going as like an endless circle. Hence, it is not a happy number. Okay, now let's see in this program here how to do with this user-defined function. First, I'm going to define a function here named happy with the parameter n. And I'm assigning two variables here with value zeros. Now I'm going through while loop, and I'm checking the condition whether the n is greater than 0 or not. If n is greater than 0, it will be going through this loop. It will be going through this loop, and it will be checking it as if it is going through the loop, and it will be returning the sum of square, and it will be 1 or not. So if it is 1, then again it will be not be getting in the loop, because whenever we get the value as 1, we will be getting the other value as 0. So we are getting the number as stopping it as in 1 itself. Okay, so if we are getting the return value as 1 here, it will be going into this main program. So whenever I go to my main program, first value, I will be getting the input from the user. So that's my first work here. So I'm getting the input from the user, and I'm storing it in res. I'm storing it in the other variable, because I can't say whether it will be same or not. So I am storing it in the other variable first of all. So now I'm gonna call this function in the same res itself, res variable itself, using a while loop. Whenever the res is not equal to 1 and not equal to 4, I can run this happy again and again. Because it has an endless cycle using a while loop here, it is an infinity loop, so it will be running through this. So I'm checking whether the res is 1 or 4. If it is not 1 and if it is not 4, it will be running through infinity times. Whenever it reaches 1 or 4, this loop gets stopped and it will be not called the happy function again, and the value will be stored it in the rest is 1 or 4 only. So again, I will be checking through if condition or else if condition. I'm not going to use else condition here. I'm going to use else if condition because I have two conditions now. I'm going to check whether the res is equal to 1 or res equal to 4. So I'm having two conditions, so I'm not going to use else condition here. I'm going to use else if condition. So in this first if condition, I'm going to print the with it is a happy number by using whenever the res is 1. If it is not 1 and it returns the value as 4, it will be printing it as it is not a happy number. So now let's check with the run program here. I'm going to run this program. It asks me the value here, and I'll be giving first as 19, which is an happy number because it runs through an endless cycle and it returns the value as 1. Look, 19 is a happy number. With the same process, I'm going to give it as 18. Okay, again, I'm going to run this program and I'll be giving the value as 18 here. Look, it is not a happy number here. So we can conclude by saying this: user-defined functions helps us to reduce our work. Now look in all these 4 programs, whenever we get a value, it will be running through infinite number of times and we should comment more, so that whenever we create a user-defined function, we can set whatever we want. We can give our own instructions here and we will call the function whenever we need here. Otherwise, we will be needing it each and every time we should run through this go and go. So by this, I can say the uses of user-defined functions has many in Python, and it is an easy working model here. So that's it, guys. I have completed my explanation on user-defined function with Python. Yeah, we'll see in our next video. Bye.